Okay, so good evening. This is the fourth problem solving session of the course Geotechnical Engineering 1. I hope I'm audible and the PPT is visible. The topic, oh, yes,
Yes, sir. Yes, sir.
yeah, okay, thanks. So, the topic of today's discussion will be soil compaction. This is the fourth week. Previously, I have, I think I have talked about soil classification, soil structure, origin of soils. Like the previous classes, in this session also, uh, this this discussion will be consisting of a set of questions, a set of MCQs, multiple select question, MSQs, true false statements, and some numericals. Since this chapter, this soil compaction, is mainly a conceptual, based chapter. So there are many conceptual questions regarding this soil compaction. So, like the previous classes, in this class also, please write down the questions. You need to write down the questions as I dictate them. I'll first dictate a set of questions. I think in this class I have approximately 20. Yes, I have 20 questions. You need to first write down the questions as I dictate them, and if others join, no need to tell the answer or write the answer in the chat box. I'll give you time to solve these questions, approximately 15 minutes. I'll give you some time to solve these questions. And after that time, in the same meeting, I will start discussing the solutions and give the explanations behind the solutions. Okay. So I'll ask you at that time to give the answers. Okay. And that will make the session kind of interactive, I hope. So I will straight away start with the PPT. Yes. So, the PPT is visible, right? Sorry. Is the PPT visible?
Yes, sir. Visible.
Okay, fine. So I'll start dictating the questions. Okay.
Yes, sir.
So the topic is soil compaction, and this is the fourth problem solving session of Geotechnical Engineering 1 course. So the first question is factors affecting compaction of a soil are. Those who have joined, please mute yourself. Yes. Factors affecting compaction of a soil are, the options are water content, soil type, compaction energy, or all of these. I repeat the question. Factors affecting compaction of a soil are, first option, water content, second option, soil type, third option, compaction energy, and last option, all of these. Okay.
Yes, sir.
Yeah. Next question. Yes. So this is a multiple select question. More than one option can be correct. The question is, for a same soil type, the effect of heavier compaction is 2. For a same soil type, the effect of heavier compaction is 2. Your options are: decrease the optimum water content. Option 2, decrease the maximum dry density. Option 3, decrease the effective shear stress. Option 4, increase the maximum dry density. I repeat the question. For a same soil type, the effect of heavier compaction is 2. The options are: decrease the optimum water content, decrease the maximum dry density, decrease the effective shear stress, or increase the maximum dry density. Okay, I hope the question was clear. Next
Yes,
question.
sir.
Yeah, okay. The water content used in field compaction is known as. The water content used in field compaction is known as. So in this uh, discussion session, you will find a lot of questions where I have asked about the actual terminologies. Okay. So even if other options might mean the same, I'm not talking about this particular question. There can be other questions where you can find that many options might mean the same. I'll be asking about the particular terminology, what it is called in standard practice. Okay. So here I have asked, the water content used in field compaction is known as. The first option is optimum water content. The second option is field water content. The third option is placement water content. And the last option is natural water content. I repeat the question. The water content used in field compaction is known as. Just a moment, someone is trying to. Yes, those who are joining, please write down the question from the current one. I think you have been there in the last session, so you know. Don't write the answer or tell the answer now. Please write down the question as I dictated. Okay, so this is the third question for the person who have joined right now. The question was, the water content used in field compaction is known as. The options are optimum water content, field water content, placement water content, or natural water content. Okay, I think the question was clear. Next question. Yes. Compaction control in the field consists of determination of. Compaction control in the field consists of determination of. Your options are water content at which the soil is compacted. Option 2, dry density achieved. Option 3, degree of compaction. Or option 4, all of these. Okay, Deepak, you have missed three questions. Please write down the questions from the current one. This is the fourth question. Okay, I'll give you time to solve these questions. There are 20 questions, I think, in this discussion session. Yes, so the question was compaction control in the field consists of determination of. The options are water content at which the soil is compacted. Option 2, dry density achieved. Option 3, degree of compaction. Or option 4, all of these. I repeat the options: water content at which the soil is compacted, dry density achieved, degree of compaction, or all of these. Yes, that is what I was afraid. Please don't write the answers now in the chat box, or don't tell the answers now. Let everyone solve and you also solve. Okay, there are many questions. I'll give you time to solve all the questions. What is Y? You first wrote D and then wrote Y. Okay, that Y was yes, sir. You missed the sentence before. No problem. Okay, anyone, someone unmuted them, him. Want to say something? Anyone? Was it ARV?
No, sir. No, sir. Proceed.
Okay, okay, fine, fine, fine. Okay, so this was the question. I believe I will go to the next question. Yes. Vibratory rollers are useful for compacting. Your options are cohesionless soils. Option 2, crushed rocks. Option 3, gravel. Option 4, clay soil.
नहीं मैं नहीं कर पा रहा है
Bhagwan Singh Lodi, please mute yourself. Yes, and please write down the question from the current one and don't write the answer or tell the answer now. I'll give you time to solve the questions. This is the problem. I have to repeat the instructions because I don't know whether this person was there in the last class or not. So, anyway, yeah, this is a generalized question. Okay, I'm asking about the type of soil. So, the answer might not be specific. This is just a hint. And those who have joined right now, this is the fifth question, by the way. I repeat the question. Vibratory rollers are useful for compacting. First option, cohesionless soils. Second option, crushed rocks. Third option, gravel. And fourth option, clay soil. Okay, I'll go to the next question. Yes. Clay particles compacted on the dry side of optimum moisture content exhibit. I repeat, clay particles compacted on the dry side of optimum moisture content exhibit. First option, single grained structure. Second option, dispersed structure. Third option, honeycombed structure. And fourth option, flocculated structure. Clay particles means the minerals in the clay particles, what kind of structure they will display after they have been compacted on the dry side of the optimum moisture content. That is, in the graph of the maximum dry density versus moisture content, there is a peak. So on the left side of the peak, it is the dry side of the optimum moisture content. Someone else is joining. Okay, did anyone join? There was a notification, but it is gone right now. Okay. Okay, I'll be repeating again. Please write down the question from the current one and don't write or tell the answer now. Okay, this is the sixth question. You'll get time to solve them. I repeat the question. Clay particles compacted on the dry side of optimum moisture content exhibit. First option, single grained structure. Second option, dispersed structure. Third option, honeycombed structure. And fourth option, flocculated structure. I hope the question was clear. Next question. Yes. Highway embankments on cohesive soils should be compacted on the dry side of the optimum moisture content to achieve. I repeat, highway embankments on cohesive soils should be compacted on the dry side of the optimum moisture content to achieve. First option, low permeability. Second option, reduced pore pressure. Third option, high strength. Fourth option, none of these. In this question, someone can say that more than one option can be correct often. But I have asked, what is the main motive behind compacting the cohesive soils for embankments on the dry side of the optimum moisture content? What is the main parameter that we want to achieve? Okay. I repeat the question. Deepak, sir, I have missed some classes due to gate preparation. Then how to cover all these? You have missed the discussion, but I think you can have access to the solved materials and the YouTube videos. This lecture session, I think, will be uploaded on YouTube, and you will be getting the links of the YouTube. I don't know how you get that because I'm not allowed to share to you directly. So all the classes you will be getting. So there is no need to worry. That's I can say. Is it okay? You'll be getting the solved PPTs and the YouTube videos of all the classes. So even if you have missed, there is no need to worry. Okay. Deepak Kushwaha.
Sir, there is a problem solving link
Yeah.
on the page. So there, if you click, you can find the 3 weeks YouTube videos, all the classes videos over there.
Okay. You get that Excel
Yes,
sheet
yes,
link. Okay. Yes. 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 Yes.
yes, yes.
That is what I'm just saying.
Yeah,
That.
problem solving session. Problem
Yes.
solving session
Yes.
on the
Yes.
left side of the this. Yes,
Yes. Yes. That's what I'm saying. That.
the 3 weeks videos are there. Yes.
Yes. Yes. Thank you.
Okay.
So this class, this recording is uploaded on the YouTube, and the link, I paste that link on that Excel sheet, shared Excel sheet. On the shared Excel sheet, I paste that link, and also I upload the solved, I think the solved PPT in a Google Drive. I think you will have access to that. Okay. Anyway, I was, which question I was in? Okay, this one. Yes, this is the, I think this is the seventh question. Okay, write down the question. Highway embankments on cohesive soils should be compacted on the dry side of the optimum moisture content to achieve. The first option is low permeability. The second option is reduced pore pressure. The third option is high strength. And the last option is none of these. Okay. Next question. Plasticity needle is used to determine, the options are plastic limit of soil, penetration resistance to control field compaction, penetration value of bitumen used in road construction, or swelling of black cotton soils. I repeat the question. Plasticity needle is used to determine plastic limit of soil, penetration resistance to control field compaction, penetration value of bitumen used in road construction, or swelling of black cotton soil. Next question. Yes. Well graded coarse grained soils attain much higher density and lower optimum water content than fine grained soil. Is this statement true or false? I repeat the statement. Well graded coarse grained soils attain much higher density and lower optimum water content than fine grained soil. Is this statement true or false? Okay. Next question. If anyone has any doubt regarding the question, understanding the question, you can raise your hand, or you can, stop me and ask me. Okay. Okay. The next question. The variables concerning the method used to compact a given soil include The variables concerning the method used to compact a given soil include, the options are manner of operation, weight of the equipment, area of contact, or time. This is a multiple select question, so more than one option can be correct. I repeat the question. The variables concerning the method used to compact a given soil include, the options are manner of operation, weight of the equipment, area of contact, or time. Okay, I hope the question was clear. Next question. Yes. Pneumatic tired rollers are suitable for, pneumatic tired rollers are suitable for, your options are gravels, cohesive soils, sand, or all of these. Here I have asked whether these pneumatic tire rollers are suitable for. Okay, so this question might be, a bit tricky if you go for the specifics, but I'm just asking for whether they are suitable for. Okay. I repeat the question. Pneumatic tire rollers are suitable for, the options are gravels, cohesive soils, sand, or all of these? Okay, I'll go to the next question. Yes, again a true false statement. The compactive effort in the modified Proctor test is roughly 4.5 times that in the standard Proctor test. I repeat, the compactive effort in the modified Proctor test is roughly 4.5 times that in the standard Proctor test. Is this statement true or false? And of course, if it is, even if it is true or if it is true or false, either way, you have to mention the value of the compactive energy to calculate the number of times it is more or less, whichever is more or less. Okay. I repeat the statement. The compactive effort in the modified Proctor test is roughly 4.5 times that in the standard Proctor test. Is this statement true or false? Just a moment. Okay. So I'll go to the next question. Yes. The number of blows required for compacting each layer of soil in a compaction test is. The number of blows required for compacting each layer of soil in a compaction test is. First option 30, second option 35, third option 45, last option 25. I repeat, the number of blows required for compacting each layer of soil in a compaction test is. The options are 30, 35, 45, or 25. Okay, someone is joining now. But is there any problem with the Google Meet? I'm getting notification, but there is no, no, there is no one in the wait list. Anyway, if I get another one, I'll check. Yes. Okay. For the person who have joined now, we are almost at the end of the uh, question dictating part. So please write down this from the current question. You have to wait. Others will solve the question. You also solve from the current question, and then all the all the all the questions. I'll give you the solutions and explain them after everyone solves all the question. Okay. So please wait and write down from the current question. The current question, I think it is question number 13, right? If I'm correct. Anyone? This is the 13th question, right?
Yes, sir.
Yes.
Okay. So the question is the number of blows for those who have joined now, the number of blows required for compacting each layer of soil in a compaction test is, the options are 30, 35, 45 or 25. Okay, I cannot. Okay, I think he was there in the last class. Yeah. Okay, this was the question. I'll go to the next question. Yes. Among the following, which one has the highest optimum moisture content? Among the following, which one has the highest optimum moisture content? First option, sand. Second option, clay. Third option, silt. Last option, gravel. I repeat the question. Among the following, which one has the highest optimum moisture content? First option is sand, second one is clay, third option is silt, last option is gravel. Okay. Okay. Next question. Yes. The line showing dry density as a function of water content in the absence of air voids is called. The line showing dry density as a function of water content in the absence of air voids is called. The options are zero saturation line, no air voids line, maximum compaction line, or saturation line. Here I am asking about the exact terminology that is used in standard textbooks. What is it called? Okay. I repeat the question. The line showing dry density as a function of water content in the absence of air voids is called? The options are zero saturation line, no air voids line, maximum compaction line, or saturation line. Okay.
Excuse me, sir.
Yes.
Sorry to interrupt. Here I don't mention the answer, but there are several saturation lines possible, no, sir?
Several saturation line is possible, that is the thing, but it might mean the same. But what I'm asking is, what is the terminology used? Okay.
You does
Yes.
it require to modify any one of the answer a little bit more or no
No,
need,
it
sir?
should be exact.
Okay.
Exact terminology. Okay.
Okay, sir. Okay, sir.
Yeah. There are actually two terminologies regarding this. Okay. I've only given one. I'll also mention the other one. Okay. Anyway, so this was the question. Now the next question. Yes. In modified Proctor test, the soil is compacted in, the options are 2 layers, 3 layers, 4 layers, or 5 layers. The very simple question. Actually, the chapter soil compaction is not too much complicated. So it's okay. I have given some simple questions, easy questions. Yeah, in modified Proctor test, the soil is compacted in how many layers? 2, 3, 4, or 5? This is the question. Okay. Okay. Next question. Yes. To avoid large swelling pressure under pavements, the soil is compacted. First option, weight of OMC. OMC means optimum moisture content. Weight of OMC. Second option, at OMC, that is at the optimum moisture content. Third option, dry of OMC, that is dry of the optimum moisture content, or none of these. I repeat the question. To avoid large swelling pressure under pavement, the soil is compacted. The options are weight of optimum moisture content, at the optimum moisture content, dry of the optimum moisture content, or none of these. Okay. So next question. Yes. The 95% saturation line and the 5% air voids line are: first option, same; second option, different; third option, might be same or different; last option, same under constant moisture content. I repeat, the 95 percentage saturation line and the 5 percentage air voids line are: first option same, second option different, third option might be same or different, last option same under constant moisture content. Okay, I hope this question was clear. Next question. Yes, this is the numerical. A soil sample has specific gravity of 2.7 and optimum moisture content of 16%. What is the theoretical maximum dry density that can be achieved for this soil? So the data mentioned over here are specific gravity, that is 2.7, and the optimum moisture content, that is 16%. So theoretically, the maximum dry density, that is the one corresponding to the optimum moisture content, what can be the value of this theoretical maximum dry density in gram per cc? The options are 0.185, 1.896, 1.885, or 1.785. You can just write down the data only, no need to write the entire question. I repeat again, a soil sample has specific gravity of 2.7 and optimum moisture content 16%. What is the theoretical maximum dry density in gram per cc that can be achieved for this soil? The options are 0.185, 1.896, 1.885, or 1.785. Okay. Okay, last question. Yes, this one you can either write down or take a screenshot, whatever is feasible. A cohesive soil yields a maximum dry density of 1.8 gram per cc at an optimum moisture content of 16% during a standard Proctor test. The specific gravity of the soil is 2.65. Determine the void ratio of the soil. That is in part A. Part B, the degree of saturation. And part C, the maximum dry density it can be further compacted to. Simply you have to use the index properties formula, apply over here, part A, part B, and also part C. Just one small minor modification the formula might need to find out the result, the maximum dry density it can be further compacted to. Just write down the data, like you can do like this, like maximum dry density equals to 1.8 gram per cc, OMC 16%, specific gravity 2.65, void ratio you could find out the E, saturation that is S, and the maximum dry density rho d max you have to find out. Okay, I repeat the question. Cohesive soil yields a maximum dry density of 1.8 gram per cc at an optimum moisture content of 16% during a standard Proctor test. The specific gravity of the soil is 2.65. You have to find out first the void ratio of the soil, the degree of saturation, and last the maximum dry density it can be further compacted to. Okay, so this was the last question. I think this session does not have so many numericals. So how much time do you need? 10 minutes, 12 minutes will be okay with you. I'll be starting then at 7:10. Will it be okay? I think 12 minutes. Yeah, okay, fine. So I'll start discussing the solutions at 7:10. Okay. Have you solved the questions? It's 7:10. Anyway, I'll start discussing. This is a recording. Yeah. Okay. All right. So the first question was factors. Okay, yes. Factors affecting compaction of a soil are. What is the answer of this question? Factors affecting compaction of a soil are water content, soil type, compaction, energy, all of these. Hello? Yes, you want to say something? What is the answer?
All of this?
All of these.
Yes, all of this, because first of all, we know that moisture content, obviously, it is important. We need to add water before we can go for the compaction procedure. Soil type, definitely, because the particle size distribution or the gradation of the soil is very important. You know, if a soil is well graded, if a soil is granular, or if a soil is cohesive, that might change the degree of compaction with the same moisture content, with the same compaction energy. For example, well graded soil, okay, particles having all sizes. So a soil mass having particles of all sizes, that will have a very good interlocking properties, that will achieve a much better compaction. Okay, so soil type is also a factor affecting compaction. And then next one, the third one was compaction energy. Obviously, the force with which we compact the soil is very important, because greater the amount of force, faster we can achieve, and higher dry density we can achieve for that given soil. So water content, soil type, compaction energy, all are factors affecting compaction of a soil. So the answer is all of these. Yes, good. Okay, next question. For a same soil type, the effect of heavier compaction is to. Any answer?
Decrease the optimum moisture content, water content.
Decrease the optimum water content. And can there be any other answer?
Increase the maximum dry density.
Very good. So it is very simple. We know there are two types of tests: standard Proctor test, modified Proctor test. One is light compaction, one is heavy compaction. So in this graph, moisture content, and this is the dry density. This is the dry density rho. So when we go for light compaction, suppose for light compaction, if the graph is like this, for heavier compaction, the graph will be like this, isn't it? So for heavier compaction, what will happen? The moisture content will decrease from this part, from this one to this point. Okay. and the dry density will increase from here to here. So with heavier compaction, we are trying to decrease the optimum moisture content, and we are also trying to increase the maximum dry density. So both of these options are correct. Okay, heavier compaction, there is a decrease in the optimum moisture content and increase in the maximum dry density. Okay. Okay, next question. The water content used in field compaction is known as, what is the answer?
Optimum water content.
Someone has said, someone has written, ARV has mentioned C. Yes, it is
It is
not.
placement.
Water content.
Yes, placement water content. It is not the optimum water content. Optimum moisture content, optimum water content is that moisture content which upon compaction, corresponding to which we obtain the maximum value of the dry density, isn't it? Okay. But in field, the water content we used in field, because the thing we do in lab and the thing we do in field, they might not be, always, and mostly often they're not always the same, because in field there are so many other factors that need to be taken care of. Okay, so optimum water content is not used in field, though corresponding to this value we obtain the maximum dry density in the laboratory. The moisture content which we use in field, in practical applications for compaction in the field, that is called placement water content. And there are many other scenarios involved. If you go through any standard, soil mechanics books, you can see, okay, for the other factors with respect to this placement water content. So yes, option C, placement water content, is the right option. Good. Next question. Just a moment.
Sir, excuse me, sir.
Yes, yes.
The answer is clear, sir. Placement water content, I have written also, it is correct.
Yes, yes.
But sometimes the placement water content can match with the OMC, can also match with the NMC. Is it correct, sir?
Yes, definitely it can match.
Yeah,
Definitely it
thank you.
can match. Definitely it
That's
can
all.
match. But the thing is, what I want to mention over here,
Yeah,
that
it's clear, sir. It's clear.
yes,
Your question is, as per your question, answer is C.
yes, yes. Just a moment. Someone is joining now. Okay. Anyway, again, I want to just repeat that someone said optimum water content, because that he or she might have thought that since that is the one giving us the maximum dry density, we can use that. We should use that. But we do not go whatever we get the value in the lab. We cannot always go with that value in the field. There are other parameters also involved. Okay, sometimes placement water content can be equal to the optimum water content, can be equal to the natural moisture content, rightly said. But when we go for the field, okay, we have to keep in mind this terminology, placement water content, for compaction of soil in the field. Okay. Okay, next question was compaction. Just a moment. Yes, compaction control in the field consists of determination of. What is the answer? Any answer? This question I think is easy. Anyone? Compaction control in the field consists of determination of which parameters? Parameter or parameters? C, degree of compaction. Just in the previous question also, there was something with respect to the, moisture content in the field compaction, right? The answer is all of these. Okay, all of these. Because when you say degree of compaction, okay, degree of compaction, what is degree of compaction? Rho d achieved divided by rho d max, right, into 100%. So unless and until we do not find rho d achieved, how can we find the degree of compaction? And along with this, the moisture content, obviously the placement water content, we know that. So we have to determine the moisture content at which you have to first know the placement water content. That's why the option is all of these. Okay. Any doubt?
Sir,
Yes.
degree of compaction in the numerator, it already includes both option 1 and 2, na, sir? For example, we find a bulk density in the field, not dry density directly.
Yes, the bulk density you find, but when we talk about the degree of compaction,
Hmm.
we put dry density as a denominator. The numerical formulation I'm talking about, right? Dry density will not be comparing with bulk density, right? So the dry density that is achieved in the laboratory or in the field, whatever, okay, and divide by the maximum dry density, that is the degree of compaction. And when we say degree of compaction or dry density achieved, okay, this numerically this does not have any moisture feature or parameters. So I have told in the question compaction control in the field. So what do we need to find out? So compaction control means when we start the compaction, when the compaction proceeds and the compaction ends. When it ends, we need to find out the dry density achieved and the optimum moisture content, that means the placement water content, the amount of moisture we need to add for which the soil to be compacted. So all these three we need to keep in mind, we need to put a check on while we go for compaction in the field. Is it clear or are you having any doubt? I think you have doubt still.
Uh,
Yes.
Still, I'm not talking about the denominator, sir. Rho max is a laboratory parameter, that's okay.
Yes, yes.
But when it comes to the numerator, rho
Hmm.
in the field, we use a core cutter or sand replacement to
Yes,
find
yes,
out.
yes.
In that, these two answers indirectly will come into picture, no? Water content and dry density. Uh,
Dry density will come in the picture. Like when we are doing that, dry
hmm.
density, moisture content is there. Okay, when you find the degree of compaction. But the thing is, are we numerically finding the moisture content in this degree of compaction? I'm not talking about the procedure. Okay, for
Yes.
example, in the field rho d I'm writing and rho d max is there. Rho d max have been found in the laboratory. Okay, so we know that this is the maximum dry density the soil can achieve, and in the field we have achieved this dry density using sampling methods and then compaction. Okay, so I have used a certain amount of water to achieve this dry density. Fine. Okay, but am I incorporating that moisture content over here? No, I have to find out the moisture content also, right? Which moisture content gave me, like in lab we draw this graph, we find out the optimum moisture content and the maximum dry density. So if we say I have found out the maximum dry density, it is this. But if we find out only rho d max, okay, we have to find out the OMC also, right? Then it is a Proctor test, compaction test, standard or modified. I get your point that you're saying that when we are trying to achieve the dry density, okay, this incorporates this, and when we are talking about achieving the dry density, we are incorporating moisture in there, like optimum moisture content. But I'm talking about the numerical, like we need to find out the OMC, that is the placement moisture content. Like when we go for the compaction in the field, there is certain moisture content which we should know for starting the procedure of compaction. That is what I'm talking about. Determination of the
Okay, sir.
OMC at field. Okay.
Okay, sir. Okay.
Yeah. So yes, all of this is the answer this question. Yeah. Next question. Vibratory rollers are useful for compacting. What is the answer? What is the answer?
Cohesionless soils.
Yes. A, cohesionless soils. Yes, cohesionless soils. So this is the generalized. I have told you that generalized answer. Gravel is also a cohesionless soil, but sands and gravels both. Why not clay soil? Because that vibration can damage the internal structure of the clay particles, clay minerals. Okay, that's why it is not used. Vibrator rollers are suitable for only cohesionless soils. Okay, not for fine grained soil, especially not for clay soils. Yes, good. Okay, next question. Yes, clay particles compacted on the dry side of optimum moisture content exhibit. What is the answer? Anyone? D. Yes, ARV.
Flocculated.
Yes, flocculated structure. That is disoriented, not oriented. Flocculated structure. And on the wet side, it becomes more oriented. Okay, or you can say dispersed structure on the wet side of the optimum. So yes, the correct answer is clay particles compacted on the dry side of the optimum moisture content exhibit flocculated structure. This is disoriented or non-oriented structure, whatever you can say. Okay. Next question.
Sir, can I have a small interaction, sir?
Yes, yes, yes. Of course.
Normally, most of the resources will
Hmm.
discuss about wet side and dry side.
Yes.
Normally, they don't discuss at the optimum. Now, it's
Yes.
same question. If you take at the optimum,
Yes.
is the I have seen some source. It is called less flocculated
At the optimum.
at the optimum.
Okay. Okay.
Uh, and similarly, can we say that at the optimum, it's also more dispersed, or which is the correct option? Less flocculated or more dispersed?
Okay. I have to say that I haven't checked. It was a
Okay,
very,
sir.
good insight you have
Yeah,
placed.
I have seen, sir. I have seen it is. For
Yes.
example, flocculated structure is also called a random oriented structure.
Random oriented. Yes. Yes. Random
Uh,
oriented. So you're talking about at this point.
yes, sir. Yes, sir.
Here it is flocculated. Here it is dispersed. So
Yeah.
this nomenclature will be, more less flocculated or more dispersed. Or
Less, yeah,
sorry,
less flocculated I have seen.
less flocculated.
Yes, sir. For example, can you give a name, sir? Extremely left as A in the compaction curve. On the peak, it is B, and at the downstream completely C.
Yes.
Now compare with A and B. A is normally called as a more flocculated.
Yes.
At B, it is called less flocculated. I have
Less
seen this. I
flocculated.
don't know what is the book. I have seen it.
Okay. Okay.
Now, for example, C, it is called dispersed.
C is dispersed.
Dispersed. But
Yes.
at the B, can we use any alternative word of dispersed? That is less dispersed or more dispersed or something.
See, the less amount of water, more flocculated. More amount of water, it is more dispersed. that's
Yes, sir, that is
that's the
correct.
way
Yeah.
it can go. So
Hmm.
as you were saying, it is, if it is more dispersed, it should be less dispersed to the point where the
Hmm.
soil is, at this point B, it is, we can say that it is less dispersed, it is also less flocculated. but
Oh.
but
Mhm.
simply stating for this particular region might not help. You have
Yeah.
to, there should be a comparison when we say more or less.
Hmm.
Okay, so I have not come across this question. This was a very, interesting question, thank you. But
Yes.
I should also definitely check this, because yes, the nomenclature and every like comparison of this, strength properties, or and size particle distribution, they are mainly mentioned on the dry side or the wet side.
Yeah.
Dry side or the
Some.
wet side, but at the optimum moisture content, it is not mentioned.
Yes, sir.
Not
And
mentioned.
in some books, I have seen they have also
Hmm.
shown the structure of soil, clay,
Hmm.
at A and B and C.
Okay, okay.
In
Yes,
between A and B also they have given.
I might have seen that. Yeah, I might have seen that.
It,
I think you're referring to BC Punmia book. I might have seen that in
some
that book
textbook.
also. Yeah,
Yeah, yeah.
so I might have seen that. But the thing is, this dry and wet of optimum. Okay, as I mentioned previously, the optimum moisture content is something which is specifically we determine from the laboratory tests, right? In the field, we don't use optimum moisture content, but
Yes.
all this kind of application based, like the forthcoming questions we have, like wet side of optimum for the pavements, for shrinkage and swelling, this kind of practical applications. I don't think this optimum moisture content which we obtain from the laboratory is much put to use, I will say. Rather
Yes.
that's placement water content, something like that. So I think that as per my understanding, this particular point, that is the point B, the point B is not put to use. Rather a generalized comparison from either less or more is being used, because when we talk about the point B, that means we are restricting ourselves to the value found out from the laboratory experiments, which cannot be fully applied or can be seldom applied to the field conditions.
A and C are more important than B.
A and C might be, like, if they are saying, because if all the resources or the textbooks, as you have mentioned, they are
Yes.
mentioning, as I have also seen, they are mentioning dry side and wet side of the optimum, then
Yes.
that being on the dry side and being on the wet side might be more important than being on the optimum, because the optimum moisture content is something we seldom use in the field. Okay, we use placement moisture content, which might fall on the dry side, which might fall on the wet side, depending upon the structure we are trying the structure we are trying to construct on that particular soil, or depending upon the strength we want to the soil to exhibit, so I think that might be one of the reason. But this question was very interesting. Thank you.
Thank you, sir. Thank you.
Yeah. So yes, the answer to this question was flocculated structure. Okay, so I'll just check. Yes, okay, it is recording. Next question was, yes, highway embankments on cohesive soil should be compacted on the dry side of the optimum moisture content to achieve. What is the answer? And I mentioned that one particular thing will be the answer, even if others might be true. Yes, C is the answer, high strength. High strength. We want the highway embankments to be of high strength so that they can resist deformation, right? They can resist deformation. So they are compacted on the dry side of the optimum moisture content. Okay, good. Next question. Plasticity needle is used to determine. This is a very simple question, I think. Any answer? Plasticity needle determine? Yes.
Plastic limiter.
No. Plastic limit. How do you determine plastic limit in the laboratory?
No equipment for plastic limiter.
Yes, no equipment for plastic limit. We, for liquid limit, we have the Cassegrain apparatus. Plastic limit has plasticity needle. Another name of plasticity needle, if I say, I think that might help you. It is also called Proctor's needle. Now say.
Second option, penetration resistance.
Yes, second option. To control field compaction. We should know, right? How much compaction. Okay. Somebody is joining right now. Sagar. Okay. The class had started from 6 o'clock. Okay. Just just follow through the solutions I'm discussing. Yes, penetration resistance to control the field compaction, because in the field also we need to know how much the soil is compacted, so we need to check, and the resistance to that plasticity needle gives us an idea how much the soil is being compacted. So plasticity needle or Proctor's needle, another name for plasticity needle, is used to find out the penetration resistance to control field compaction. Okay. Okay, next question. Yes, well-graded coarse grain soils attain much higher density and lower optimum moisture content than fine grain soils. What is the answer? True. Explain, please, why it is true.
Fine grain soils, actually water holding soils, they have negative charges, hence it consume more OMC.
Yes, it consumes more water. Specific surface is also a parameter with respect to that. They need more lubrication firstly. So coarse grain soils, so fine grain soils will need more water. So obviously coarse grain soil will need less water. So lower optimum moisture content, and definitely, and another parameter also I mentioned, well graded. Well graded. That means the soil sample, even if it is coarse grain soil, it has samples of all the particle sizes. So the interlocking property will be very high for well graded soil. There is the particles filling up the voids of the bigger particles. So here compaction will be easier, and with the same compactive effort we can obtain higher density. As I mentioned in the previous question, that is, the compaction depends on the soil type, the degree of compaction, and the moisture content. Okay, so it is coarse grained soil and well graded, so obviously it will have higher density and lower optimum moisture content than the fine grained soil. The statement is true. Good.
Sir,
Yes.
can we give the answer in other way? For example,
Yes.
well graded coarse grain soil.
Yes.
Generally, they are water draining soil. They cannot hold the higher moisture.
Yes. Yes.
Hmm.
Yes. 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 Good. Very
Possible,
good.
sir?
Yes. Yes. Very good. They are water draining soils, as you have mentioned. Yeah, as you have mentioned. I just shifted your what to say, explanation from
To the
the,
fine grain soil.
no, not to the fine
Hmm.
grained soil. Your explanation was towards the water holding capacity and charges, right?
Yes.
I shifted that explanation to the specific surface. So both are correct. I think combined, okay, not one property. See, fine grained soil, they are water holding soil, and because they have more specific surface, they need to be lubricated more to achieve a particular dry density. Whereas coarse grain soil, they are water draining soil. Okay, they are water draining soil, and also they have less specific surface, that is surface area per unit mass. So they need lesser amount of lubrication. On top of it, it is well graded. Okay, so it will be having higher density and lower optimum moisture content. Yes, very good. Okay, so this was the question. Next one. The variables concerning the method used to compact a given soil include. Answer. What is the answer? Gaurav Shah is joining now. Those of you who are joining now, the class has started from 6 o'clock. Okay. Variables concerning the method. Yes, someone has given A, B, and C only. What about time? I'm not talking about attainment of high, maximum dry density. Okay. If you go on compacting for more time, what will happen?
It is actually compaction itself is an instant process, no, sir?
Yes, instant
Therefore, you
process.
don't have any significant improvement.
Yes, I understand, but here actually the question might have been framed in a bit different way. I mean to say, for example, I am giving 25 blows. Okay, I increase the force and I give only 5 blows. I decrease the time, time of compaction. Okay, so will that affect the compaction?
Yeah, energy affects the compaction, sir. But
Energy
number of passes also affect the compaction.
affect the compression. So I'm not, when I say time over here, just I just want to clarify. Okay, 1 2 3 are obviously correct because we know weight and manner of operation and area of contact also. But when I say time, okay, and I'm not talking about the long term process like consolidation. Okay, I'm talking about instantaneous time only. Suppose I have a soil sample. Okay, I give 3 blows and then I stop, and then on the same soil sample with every other parameters constant, I constantly go on giving, after 3 4 blows, 5 blows, 6 blows. So the number of blows are increased with the number of time, right? So in that aspect, time will affect the degree of compaction, isn't it? What do you think?
I don't think, sir, time. For example, I don't know. I will give you another way of relation. If
Yes,
you
yes,
take a
yes,
concrete
yes,
mixture,
yes, yes.
either you go for 1 minute mixing or 1.5 minute or 2 minute, 3 minute, you don't have any significant improvement. Only waste of the time.
That is
That was as per.
that is after a particular time. See, I am compacting. Okay, I am starting from here to here. Suppose this is the time span. Okay, at this point of time, I will achieve the maximum dye density. Okay, fine, at this point of time. But if I stop here, so between this, okay, between this, if I stop early, I will not be achieving the maximum dye density. I need to do it more, right? So till we achieve the maximum compaction, okay, we cannot stop before. So within this time, till we achieve the maximum value of dye density, time is significant for that particular time, and that is doesn't matter if it is a small time or spontaneous action. Okay, it is not like you take a soil sample and you just give it one blow and it is compacted, right? In laboratory also, in the laboratory standard proctor test also, we need to give 25 number of blows, right? We cannot just give 5 or 6 blows and say it is completed. The compactive energy is one point, but along with the compactive energy there is time involved. Okay, till this point I agree your statement that it is not like we need to do it for a, the larger we do it, the longer we do it, the longer the better the compaction. It's not like that. Okay, but till a particular amount of what to say, particular magnitude of dye density is being reached, till then we need to take care of the time, right? We need to go towards it, isn't it? If you have any doubt, you can tell again. No worries. Who was asking the question? I think ARV. Yes.
No, sir. If this answer D, if you modify a little bit, I can think of, but I have not seen anywhere this time factor particularly. Even in factors affecting compaction, also time is not included.
Factors affecting compaction. See, this question is not that generalized topic with
Hmm.
respect to which we try to differentiate compaction and consolidation. No. Okay. See,
Hmm.
this one you agree, right? That from here till here, we need a certain amount of time to achieve the dye density. We cannot have it instantly. Okay, but that time, that this time might be insignificant to the time required for consolidation. We all know that. Okay, but even this amount of time in the initial phase of compaction is important. Like I said, in the laboratory, when we go for the standard proctor test or modified proctor test, okay, for standard proctor test, for each layer we have to give a certain number of blows. We cannot say that I will give only 5 or 6 blows in a very high force and just stop it. No, we have to go on doing that. It is a continuous process, otherwise the compactive effort, even though the compactive energy is increasing in the modified proctor test, we have to give the same number of blows, right, per layer. This is the thing. Even though the compactive energy is increasing, and even though the number of layers is decreasing, for one particular layer, we are giving the same number of blows. So that particular, compactive effort, giving the compactive effort, that takes time, and I'm talking about that time. Yes, obviously that the question can be written in a better way, like initial time or something like that, isn't it? What do you suggest?
Sir, what I am asking here is, for
Yes,
example,
yes,
one person was doing the compaction and he's applying a 25 blows in 10 minutes.
yes,
Another person was doing the same thing, but
yes.
because of his weak, he's applying the same energy after in 25 minutes or something. In both the cases, energy is same, but time is different. In normally we used to see in laboratory sometimes strong person will be there, sometimes weak person will be there.
That is
Uh,
okay. That is fine.
that is actually blows will affect.
Yeah, that is fine. Then even if it is like, okay, in when it is manually controlled. You're asking when it is manually controlled, right? The compactive
Hmm.
energy is different, so it will be different. Time is different. So again, in here also, time is playing an effort because the compactive energy is less. But when it is, not manually controlled, when it is not manually controlled, then also, then both the machines will take the same time, right? For each layer, because it is
Yes, sir.
not manually controlled. So the machine cannot see if the machine is giving the force, for example, like A, right? So 10 minutes have to be taken into consideration, right, for compaction. So 10 minutes is not spontaneous, it is a fixed amount of time that is being taken. The machine itself is taking 10 minutes to give a certain number of blows to compact one particular layer. So in this case, time is important, right? Because if it decreases the number of blows, time automatically reduces. And over here, just see the options over here. The manner of operation, that is your statement of manual or machine operated, the weight of the equipment, and the area of contact. And time. I have not talked about the number of blows over here. And I think I have given this question from somewhere because this was the question. I have not talked about the number of blows over here. Okay. So if I would have considered the number of blows over here, I think at that time, anyone has put their mic on. I think there is noise.
Yes, sir. It's myself.
Okay, okay, fine. Yeah, I have not given the number of blows over here as an option. If I had given the number of blows over here as an option, then time would might not have been the correct one because the number of blows is automatically saying us how much time do we need, right? You just remove the manual part, go for the mechanical part. The machine is giving the machine is doing the thing, the machine is compacting the soil. Now the number of blows, supports now it is standardized to a value, I'll just say it later. Suppose 10 blows it has to give, so 10 blows will take a certain amount of time, right? This question is with respect to that amount of time required for compacting one layer of soil in the laboratory, similar to that. I'm not talking about time in the context of the the more we increase the time, the more the more compacted the soil will be. No, not that. We need a certain amount of time with a certain number of blows to compact a layer. That is what I'm asking over here. Am I able to understand, make you understand the point? I also believe the question can be modified. So if you have any suggestion, you can tell me now. I'll just
No,
modify the.
sir. It's okay. I understood what you're telling, but
Yes.
only my concern here is in none of the textbook I have seen this as a factor anywhere. They have not discussed of time actually. If there is a source, I can still I can go ahead and I can update also. No
Okay,
problem.
I will try to search for the source.
For
Okay.
example,
Yes,
for
yes,
example, if the
yes.
last option, if you have written this as a number of passes or number
Number
of
of
blows,
blows. Yes,
that will be fine. That will be fine.
that will be better. Yes,
Yeah, that will be better.
that
So
will be
that's
better. But the source from where I have mentioned
okay.
this
Okay.
question, and
Okay.
what I also have read, that is this number of blows is
Hmm.
automatically
Hmm.
governing the time we need to compact
Okay.
one particular layer. Okay, generally
Okay.
I understand your concern. Generally, when we study like compaction and consolidation difference, that is time dependent is consolidation, compaction is not time dependent.
Hmm.
Okay, so when we say time in the case of compaction, generally it is not a proper way of saying, because it generally goes with consolidation. We have equation also in consolidation, right? The differential equation governing the time and everything. So I understand that, but here in this case, number of blows, the time which is governed by the number of blows for compacting a layer,
Yeah.
which
Even
is
even even in the field also, if you take other than laboratory,
yes, yes,
laboratory number of blows will come for dynamic method. But
yes,
in the field, normally we have a number of roller passes.
yeah, number of
Uh,
blows, yes, obvious number of blows in the
yeah,
laboratory or number of passes,
passes. If you
number
take a
of
number of
passes,
passes in the field,
yes,
does it that it gives a the is slowly if the roller is passing, does it indicates that compaction is more effective?
See, that is the thing. Slowly, if it is passing, if it is moving fast, okay. It also depends on many things like manner of operation, weight of the equipment,
Yeah.
type of soil also.
Yes, sir.
Okay,
Yes, sir.
type of soil, the inherent moisture content. Okay, so I understand your concern, but when I say time over here, I keep in mind that it is not with respect to what it holds for the consolidation part. No, not that.
Yeah.
It is the initial phase where we give a certain amount of compactive energy, and that needs a certain amount of time to compact a certain layer of soil. Okay, that's the simple thing. Okay.
Okay, sir. Okay,
Yeah.
sir.
Okay. These ways classes can get very interactive. It's good. Others also can give their opinions and say some answers. Okay, next question anyway. Pneumatic tired rollers are suitable for. What is the answer? Again, one person is only answering D. Yes, all of these. I have mentioned suitable for. They go with pressure and kneading. Okay, like you can search the pressure and kneading part in any standard textbooks. So gravels, cohesive soils and cohesionless soils both can be done using pneumatic tired rollers. It is suitable for all the type of soils because it has good compactive compaction technique. Okay, and I have mentioned here suitable for. Okay, this might be better suited. uh, in some places I've seen it is said that it is better suited for well graded soil. In some places it is said better suited for fine sands or silty sand. Okay, but suitable for, that means it can be applied to all kinds of soil. It can go with a particular soil in a better way, but it is suitable for all type of soils. Okay, so just keep in mind the terms used in the question. Anyway. Okay, so just a moment. Yes, so the answer is all of these. Next question. Yes, compactive effort in the modified Proctor test roughly 4.5 times that in the standard Proctor test. What is the answer?
True.
True. Someone said true. What is the approximate value of the compactive energy for the standard Proctor test? 4.22. No, not 4.22. I'm asking about the compactive energy in kilojoule per meter cubic, if you can say, because in that way I don't have to convert it, what I have written in my notes. 4.22
Around 2700 kilojoules
kilojoule per meter cube in standard Proctor test.
in modified Proctor test.
Yeah, modified Proctor test. I have
It is
seen.
around 597 something in
Yes,
standard
yes,
Proctor
yes,
test.
yes. As per I have written, you are right. You are nearby. This modified Proctor test, the compactive energy is 2674. Yes, 2674 kilojoule, sorry, kilojoule per meter cube. And for standard Proctor test, it is how much? As per I've written, 595. Yes, 595 kilojoule per meter cube. Okay, so it is roughly 4.5 times. Okay, let's see once. Yes, next question. Yes, number of blows required for compacting each layer. Very simple question. What is the answer?
25.
25. Yes. In any compaction test, for compacting each layer, we need 25 number of blows. Among the following, which one has the highest optimum moisture content?
Clay.
Clay has the highest optimum moisture content. Yes, clay has the highest optimum moisture content. Why? Again, that surface, specific surface will come into play. Okay, there is a graph where some types of soils have been mentioned. Okay, where is the graph? Yeah, this is the moisture content, this is the dry density. Okay, so 1, 2, 3, 4, 4, and yeah, like this. The lowest one will be clay of high plasticity, and then this is the clay of low plasticity. This is silt, low plasticity silt. This is well graded sand, and this one is well graded gravel. So sand and gravel, they generally have low optimum moisture content, and clay have high values of optimum moisture content. So yes, the answer is clay. They have highest optimum moisture content among all the other soils. Okay. Okay, next question. The line showing dry density as a function of water contained in the absence of air void is called, what is the terminology? D. Very good. Saturation line, it is also called zero air voids line. We don't call the line as no air voids line. Okay, or maximum compaction line, even though they might hint towards the same thing. The actual terminology is saturation line or zero air voids line, the exact terms. Okay.
Sir,
Okay.
excuse
Yes.
me, sir.
Yes. Yes. Yes.
When you are dictating this question, I raised a small concern in the question here.
Yes. Yes.
For example, option A, you have mentioned very clearly zero saturation line.
Yes.
But why option D you didn't mention 100% saturation line?
See, saturation line is a terminology used in place of zero air voids line. That is the standard term we show when we say that line showing dye density is a function of water content in the absence of air voids. Okay, that means 100% saturation. When we say the soil is saturated, saturated means 100%. If it is less than 100% by standard nomenclature, then we should, or the sources should mention that it is partially saturated. When we say
Sir,
this,
you have written in the option D / zero air voids line.
yes,
Then why
yes,
you have mentioned zero air voids line? You can mention simply air voids line.
no, zero air voids line I have not mentioned. This is the terminology for that particular line showing. Zero air voids means air voids line and zero air voids. And zero air voids, there are no more air voids. All
Na is
the,
equal to 0.
yes, there are no more air voids, and all the voids have been filled with water. So zero air voids means saturated. Simple thing. Okay, I have written zero air voids line, but saturation line. See, air voids I have to write zero air void or something. But when we say, in general sense, when we say a soil is saturated, a saturated soil, that means S equals to 1. By default, you should consider that. If it is less than 1 or 100%, whatever, then we should write partially saturated.
Yeah, that's okay, sir. If you give the saturation line last option as a 100% saturation line, it will be further very clear, no?
It can be clear, but I have not created this terminology. This nomenclature I have not created. It is there in the books. It is there in the standard books, soil mechanics books. Okay, this is the nomenclature. If I would have gone by the by the terminologies which we can mention, we can say, then with that, on that basis, this one could have been the right option also, right? No air words line, zero air words and no air words line. But I'm not talking about what we can call it. I'm talking about what it is called. As per standard textbook, as per the nomenclature. Okay, it is called saturation line or zero air voids line. Even though zero air voids and no air voids means the same thing, but the actual nomenclature terminology is zero air void line or saturation line. Okay.
Okay. If the answer is given 100% saturated, we can take also that.
Yes, but then if here I would have mentioned 100% saturation line, okay,
Yeah, yeah.
then that is not what it is called.
Yes, sir. Understood. Understood.
Okay, yeah,
Yeah.
that was the concern. Okay, fine. Next question. In modified Proctor test, the soil is compacted in how many layers? How many layers? 5 layers.
Five, sir.
Yes, and in standard Proctor test,
Three.
3 layers. Just a moment. Yeah, hello, am I audible?
Yes, sir.
Yeah, so it is 5 layers, right? And 3 layers is for the standard Proctor test. Others should also, give some answers. Other people are not interacting. Anyway, to avoid large swelling pressure under pavements, the soil is compacted. This is also, I think, easy.
Dry of OMC.
No. Weight of OMC, yes. What is the reason for compacting the soil? Weight of OMC? What is the reason for compacting the soil? Weight of OMC? Because if we compact the soil, weight of OMC, then we can prevent accidental increment in pore pressure when water is added. Because if we go beyond the optimum moisture content, we are going towards saturation, and then the pores are already filled up, so there won't be any accidental build up of pore pressure that might cause large swelling. So accidental increment, or this what to say, when we add water to any dry soil, there are many pore spaces to filled up. Okay, that causes, sometimes it causes large swelling in a very small amount of time. That's what I mean by the terms accidental increment in pore pressure. Okay, so for that purpose it is compacted weight of OMC. Okay. Okay, this was also, I think, easy. Next question. Yes, the 95% saturation line, the 5% air voids line are, what is the answer? Same, different? 95% saturation line and 5% air voids line. Any answer? B, different. Yes, it is true. B is the right answer. I'll just write over here the explanation for them first. This is the saturation. What do we make saturation? Volume of water by volume of voids into 100 percentage. What is air voids? Percentage air voids. It is NA. And just write NA.
VA by total V.
Yes, percentage air voids. It is VA by total V into 100. So these two variables, they're not complementing each other, are they? They're not. We have used VV over here, that is volume of the voids over here. We have used volume of the total volume of the soil mass over here. Now had I said over here air content, AC, air content, which is volume of air by the volume of voids. The fraction, this fraction and this fraction gives us 1, right, upon addition. So 95% saturation line would mean the 5% air content line. Okay, but not the 5% air voids line. So these two are different. Is it clear, everyone?
Yes, sir.
Yeah. Okay. Now the last, I think, numericals. What is the answer you have got for the dry density, theoretical maximum dry density?
Sir, a small question, sir. Back,
Yes.
if possible.
Yes. Yes.
Uh, can you draw any one of the lines, sir? Any one of the saturation line and theoretical line and graph?
Graph. Okay.
Yeah,
Just a
some
moment.
small.
Just a moment. Let me see. You want to ask a question on the graph, right?
Yes, sir. Yes, sir.
Okay. Just a moment.
In the left side itself, you can draw, sir, on the small area.
Yes. The book which I am referring to, it has a graph like this.
Yes, sir. Rho versus water content.
Rho D versus moisture content, and this is
Any one of the theoretical line.
95% Na, 5%, 5.5% air words line. It is being shown over here like this.
Yeah.
Yes. Yes. Now.
Yeah, my question here is just a discussion only. It is.
Yes. Yes.
Uh, is this line touches both the y axis, x and y axis anywhere,
Does the line touch both the x and y axis? Okay.
or
So
either both or any one of them?
okay. Okay.
That's
So
my question, sir.
yes, if it touches the x axis, what would that mean? It would mean dry density equal to 0.
Yeah.
Okay. If it touches the y axis, what would that mean? Moisture content equal to 0.
Hmm.
Okay. So if the soil is dry, what is moisture content? What is moisture content?
0.
No, no, the definition I'm talking about.
Weight,
Moisture
weight
content,
of the water by weight of the solids.
weight of water by weight of soil solids. So this can be 0, right? Theoretically,
Yes, sir.
dry soil. So if any one line, suppose I have drawn this NA, that is, it represents the percentage air voids. Sorry, uh, suppose saturation line. Okay, suppose saturation line. If it goes touches over here, okay, it means 0. Moisture content is 0. That means the volume of water is also 0. Okay, and if it touches this one, then is it theoretically possible dry density equal to 0?
The curve itself is a theoretical curve, sir.
Yeah,
Again, again, whether it touches or not, the say. Normally, I have not observed in any of the test
yeah,
books.
it does not touch. I don't believe
Okay.
it touch because see here we are talking about the parameter which we are talking about on the rho D, isn't it? Rho D, the parameter, if it touches the y-axis, moisture content equal to 0. Now moisture content equal to 0, and we are talking about the saturation line, and moisture content we mean weight. So we are talking about weights over here, we are talking about volume over here. Okay, so first of all, it might be difficult to correlate using these three lines and you know taking this as a parameter firstly, and I don't believe theoretically it is possible that rho d equal to 0 for any
Why
kind of
why
soil.
I asked this question is,
Yeah.
for example, if you assume the dry density as a gram per cc,
Yes.
exactly at the W is equal to 0 point, dry density becomes a specific gravity.
At
Highest possible dry density, theoretical dry density is equivalent to specific gravity if it touches.
yes, that means I think it will give us the density of the soil solids only, isn't
Yes,
it?
sir.
Soil
Uh,
solids.
hmm,
Yeah, that is, yeah, that's what I said, that moisture content 0 will be possible. So the thing which will happen over here is it can be theoretically possible. Okay,
hmm.
and this will become rho s. But then how can you correlate these two parameters using these graphs? That might be a bit of a hitch.
Hmm.
Okay, I think it will be explainable. It can be, but can be a hitch. And in the second case, coming to this one, touching the x-axis, over here and saying that density equal to 0. That I don't believe it will be like
Yeah,
possible, but
yeah.
theoretically it can be
Yeah,
done.
density minimum is possible always, maybe zero
Minimum
point
is
0.6, zero point
possible,
0.5, some
obviously 0 is not
zero never
possible.
possible.
So yes,
Okay,
so it is, the graph will not touch, I think, any of the axis.
X-axis.
Yeah.
Okay, sir. I will also still spend some time on this.
Yeah, me too, me too, thanks.
Thank you, sir. Thank you.
Yeah. So yes, what is the answer of this question? I think you have found out. It's a very simple question. Anyone? Okay, anyway, simple formula based problem. I'll just solve it. This is the formula, rho d max 1 plus rho g by s. Now theoretical maximum dry density for this, what do we take? S equals to 1, right? Saturation equals to 1. Moisture content 16%. Soil is fully saturated. That level of compaction we are trying to achieve. The soil is fully compacted. So in this case, just rho W, I have asked to find this in gram per cc. Rho W is 1 gram per cc. G is given 2.7. Moisture content 0.16. Put the values, I think you will get 1.885. Isn't it? Yes, C. Okay, you have given the answer C. Okay, fine. C. Okay. Yes, 1.885. Okay. So rho d max equals to, not rho d max, I will not write rho d max because I am taking S equals to 1, then this becomes rho d max. Okay. So in generally, this is rho d equals to G rho W divided by 1 plus Wg by S, depending on saturation. If S equals to 1, then rho d becomes rho d max. Okay. Okay. Next question. What is the answer of the first part? The void ratio. Have you given the answer? I'm not getting any notification. Okay, no, you haven't. What is the answer of the first part? What is the value you have obtained if you have done this question? Yes, someone has answered, I think. 0.488. Yeah, I have obtained 0.4722. Okay, nearby. I'll just write it. Void ratio equals to G rho W, this is equals to 1 by rho D minus 1. 0. The answer I have obtained is 4722. Okay. Okay. Next question, degree of saturation. S equals to Wg by E. Moisture content divided by specific gravity into specific gravity divided by the void ratio. Any answer again? So I believe these formulas are quite common. These are there in the standard textbooks in the initial part, like index properties and all those things. So you should go through these formulas. So the degree of saturation is moisture content multiplied by specific gravity divided by the void ratio. We get in fraction this value multiplied by 100. Obviously, we do it multiplied by 100 to obtain the value in percentage. 89.78. Yes, yes. Now the maximum dry density. Again, for the maximum dry density, what do we need to do? What is the formula? Rho d max equals to G rho W divided by 1 plus Wg by S. right? 1.86, very good, 1.86. But I want to tell you something. Do not use the one you have used in the obtained in the previous answer, like s equals to 0.8979. Sorry, I've asked about the maximum dye density, right? So that will be obtained only if s equals to 1. Okay, and the value we get is 1.86 approximately gram per cc. Okay, any doubt, anyone? This was quite an interactive session. So, does anyone have any doubt regarding the questions?
Sir, a small query, sir.
Yes,
Small,
yes,
very small.
yes, yes.
Why actually the y-axis they use always dry density instead of bulk density? There was somewhere I have seen this question in some
Okay.
laboratory compaction curve. We use always dry density as a y-axis.
What is the dye density formula?
G rho W by 1 plus C.
No, 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 no.
Otherwise, basic formula MS by
Basic. MS by V,
MS by
right?
total volume.
And what is the formula for bulk density? Total mass.
Yeah, mass by volume. Both are variables.
Mass of solids. So I haven't come across this question, but I think it might be because bulk density, it consists the entire mass. Okay, it
Yeah,
consists the entire mass, and when you're talking about the entire mass, for example, we are adding water, right? We are adding, like when we compact, when we go for total compaction test, we are adding water. Okay, so when we go on adding water, like we have table over here, moisture content, first trial, second trial, third trial, fourth trial. Okay,
yes,
with the increment of water, this mass will change, right? This mass will change. We are trying to compact the soil. Volume should be minimum as per the compaction, and also not for the volume to be minimum. I just take that back. There is a particular volume of the total mold, right? That is taken into consideration for this compaction. But the mass over here for bulk density, it is the total mass. Now, if you consider the soil to be compacted, even if it is like no, obviously air has no mass, so it will be the mass of moisture and the solids, which is variable, right? Isn't it variable for the number of trials we perform to obtain this? But mass of solids is not body, it's not variable, right?
yes, sir. I am guessing that only because bulk density, both numerator denominator are variable.
Yeah,
Dry density only
no,
numerator is a
denominator,
constant.
see, denominator, this volume, which volume you
Yeah.
take? Volume of the mold only you take, right? So when we
Okay,
do
sir.
the laboratory test, we first write down the volume, like 1000 cc, I guess we take 1000 cc, right?
Yeah.
1000 cc we take. This is the volume, this is the V. Now the mass, if we take the bulk density only, then that is something which is variable,
Mm.
so no
Yes.
matter how many tests we do, the mass will always constantly go on changing, and it will be difficult for us to compare, like where we are getting the exact maximum value and the minimum values or something like that. So I think, as per my understanding, because it considers only the mass of the soil solids, that's why we take the dry density only. Okay.
Okay. Okay, sir. Done.
Okay, fine. So
Thank you. Thank you,
yes,
sir.
thank you for this interactive session. uh, I believe this was, I suppose this was the most interactive session I have done so far. So I also have got some, very good insights into this particular topic. So many things to look up to again. Uh, Thank you for attending the class. We'll again meet on the coming Friday with the fifth live discussion session. Okay. Have a good evening. Thank you.